Okay, my plan is to get through as far as I can, really. I've got about an hour and 15, hour and 20 minutes. So we'll see what we can get through in that amount of time. Hopefully at least the no calculator multiple choice. We'll see how far we get into the calculator one. So here we go. This is the 2015 practice test, and we'll just again see how far we can get. So looking at this, we're looking at an integral. So I'm going to do a u substitution. I'm going to let u equal 2x, the exponent part. And so du equals 2 dx. And so 1/2 du equals dx. And the 5 I'm just going to bring out in front. And so it becomes 5/2 e to the 2x. Because the derivative of e to the 2x is the same as e to the 2x. So it's the integral. And then I get plus ln x. And don't forget the plus c. So looking at that, that would be letter B. Don't forget your absolute value. Also, with it being multiple choice, we don't have to remember it because they kind of help us with that. Looking for the derivative, I'm going to rewrite f of x as x to the 1/2. And I'll rewrite this as 3 times x to the negative 1/2. Because 1/, means the negative exponent. And now we're down to product or a power rule. Bring the 1/2 down, multiply it in front. Decrease the exponent by 1. Bring the 1/2 down, multiply by what's out in front. Decrease the exponent by 1. We are looking for f prime at 4. Plugging in 4, I get 1/2. Let's rewrite this again as 1/, the square root of 4, minus 3/2 times 1/, the square root of 4 cubed. Square root of 4 is 2, so this becomes 1/2 times 1/2, which is 1/4, minus 3/2. Like we just said, the square root of 4 is 2, and 2 cubed is 8, so this becomes 1/8. And so I get 1/4 minus 3/16. 1/4 is 4/16, and 4/16 minus 3/16 is equal to 1/16. Letter A. Number 3, maybe? Question 3. Integrating. Again, I will do a u substitution. The entire inside function. Remember, on a u substitution, a couple of my thought processes are it's an inside of a function, it's a denominator, which can still be considered as the inside of a function. Those are really the big ones. So I'm going to make u my inside function, x cubed plus 5. And so du equals 3x squared dx. I see an x squared dx, but I don't see a 3, so I will divide. And I get x squared dx. So my x squared and my dx come out, and I get the integral of u raised to the 6th power. 1/3 du goes in its place. Integrating that gives me 1/3 times, bring the, increase the exponent by 1, right? So I get 1/7 times u to the 7th, correct? Plus c. And when I look at that, I see letter E without even going much further. I get 1/21, and the only one up there that has 1/21 is E. But I would bring the u back in if I were to do this on like on a free response or something. And then don't forget my plus c. Okay? Number 4. First thing, we recognize that we're looking for a Riemann sum. And what else does it tell me? Subintervals, they tell me the subintervals actually, so that's kind of nice. And so we're just looking at a basic Riemann sum. The left-hand side of the interval is going to tell me the y value. So my base is 25, the distance from 0 to 25. My height is the left-hand side, so it's the 4, plus my distance here is 5, times the height, which is the left-hand side. The distance here is 20, and my height is the left-hand side. And work it out. 4 times 25 is 100. 5 times 6 is 30. 20 times 30. Oh, wow, where'd I get the 20? This is not 30, that's 8. Hopefully someone caught me there. 20 times 8 would be 160. And I get 130 plus 160 is 290. All right. One thing to think about as you are listening to me talk, this is the first time I've seen these so I am going to be doing some talking out loud, and maybe that helps you. Hopefully it doesn't hurt you, but hopefully you hear my thought process, and I will try to vocalize what I am thinking. All right, so f of x equals that mess, and we're looking for a constant so that it is continuous as at x equals 2. We've seen this a few times now. Sometimes they ask for continuous and differentiable. This one is just continuous. So where these two functions come together, I'm just drawing some random function, where this value or function ends on the left-hand side and where this function begins on the right-hand side, if it's going to be continuous, they have to intersect or come together at the same y value. So I will look at the y value when I plug in 2 to the top equation. That's 2 pi. When I plug in 2 into the bottom equation, what is that, 2c? Those two values, or those two y values, have to be the same. Plugged in 2 for x in both the top definition and in the bottom definition. So sine of 2 pi, we need to know our exact values. Sine of 2 pi is 0, so 4 times 0 is 0. On the right-hand side, I get negative 14. I add 14. I divide by 2. And c is 7, letter B. All right. Question 6. Which of the following is the antiderivative? Antiderivative is basically the indefinite integral. So secant, the integral of 3 secant squared x plus 2. Forget the plus 2 for a second, because remember I can split that into the integral of secant squared plus the integral of 2, right? Throw the 3 in front. I can split them up. So derivative of what function is secant squared? Tangent. So this becomes 3 tangent, and the derivative of what function is 2? 2x. 3 tangent plus 2x. I see B. Question 7. Remember, hit pause whenever you want. I'm just trying to keep on rolling, see how far we can get. We know function f. Function g is some differentiable function, and we know that f, what we're looking for, the derivative of that mess. Okay? Chain rule. Derivative of the outside function with the inside function plugged in. Some of us are trying to do 2 steps at once. Leave the inside function alone when you take the derivative of the outside function. One more time. In chain rule, leave the inside function alone when you take the derivative of the outside function. Leave it alone. Now, once that is done, we are going to multiply by the derivative of the inside function. Okay? So there's what we got so far. And it says g is differentiable. What is the derivative of that mess? So I know f, right? So what is f prime of x? F prime of x would be 2x, right? But we want f prime of g of x. So if f of x is equal to 2x, then we have, how are these two functions related? That is the question. Okay, so the relationship between those two things is, I'm going to actually change what I just wrote there, kind of thinking quickly on the fly here. I'm going to go back to my original definition. F of x equals x squared minus 4, right? So what if I use my definition of f of g of x? What if I, back here, what if I said, what is f of 4? When x is 4, we plug in 4, right? Well, now I have f of g of x, so I simply need to plug in g of x wherever there's an x, just like I would if it was a value. So now find the derivative of that. F prime of g of x equals 2 times g prime of, sorry, leave the inside function alone, Troy, times the derivative of the inside function. Sorry, you really get to hear me talking to myself now. All right, so there's my answer. Letter D. Make sense? When I got to here, I realized I don't know the relationship between f and g. So I went back and I looked at the original function and I just used what they told me and I plugged in g of x into the original function of f. And that gave me the relationship between f and g, so then I could find the derivative. I still don't know what g looks like, but once I did know, I could plug it in and I could solve. All right, that was a good one. Question 8. We have a slope field shown, differential equation given, y is some solution to the differential equation with that condition. What is the limit as x goes to infinity of g of x? So y is equal to g of x. We probably should solve this thing for y, correct? How do you want to do that? Here's what I'm going to do. I have dy over y squared times 4 minus y squared equals dx. And there's my function. G is equal to y. So if I were to plug in or look for my derivative, all right, so looking at this, I'm going to change my thought process. Don't see a way of finding the integral of that very nicely. So let's go back and look at the other dy dx. If I look at my initial condition at -2, -1, well, that's not quite -1 there because we're counting by somewhere right in here probably. -2, -1, somewhere over in here, counting by 1, 2, anyways, somewhere right in there. We know that that's my initial condition at -2, -1 as x goes to infinity. So picture drawing my general solution starting from this initial condition, meaning we're going to now draw the particular solution. Following this slope field, it goes up, then it flattens out here, then it flattens out here. What happens as y approaches 0? Look at my derivative. When y is 0, I get 0 times 4, which is 0. My slope goes to 0, and this will flatten out to 0. It cannot cross that line. It cannot cross 0, no matter how big x gets, even when x is going to infinity. Okay, so even when x goes to infinity, my derivative, my dy dx, can't be bigger than 0. So it approaches 0. Number 9, f double prime is equal to that mess. The graph is concave up, so my second derivative is positive when? That is my second derivative already, correct? Be careful, notice what they're giving you. They're giving you the second derivative. Second derivative is positive when? Well, it's 0 at -2 and at 0. When x is bigger than 0, like 3 or 4 or something like that, this is going to be a positive. When x is less than 0, between Negative 2 and negative 1, something like a negative 1. This is negative because I have a negative 1 times a positive whatever. And then when I go to the left of negative 2, something like a negative 3, this becomes a negative 3, and this stays positive because of that squared. So it's still negative. Concave up when x is greater than 0. All right. Number 10, y is equal to that mess. Find dy dx at pi over 3. So dy dx, y prime. It is power rule, or sorry, product rule. Derivative of the first, sine is cosine, times cosine. So derivative of the first and the second, plus the first, times the derivative of the second. Derivative of cosine is negative sine. And we have y prime equals cosine squared x minus sine squared x. Correct? So plug in our pi over 3. What is the cosine of, remember this is the cosine of pi over 3 squared, right? Correct? Okay. So pi over 3. 30, 60, 90 triangle. This is my 60. I have 1, I have 2, and I have square root of 3. And we're looking for this guy up here. Cosine is adjacent over hypotenuse, so this becomes a 1/2. Pi over 3 is in the first quadrant, so it stays positive. Minus sine of pi over 2, or sorry, sine of pi over 3. What is the sine of pi over 3? So we have right here, sorry, we're not there, we're right here, pi over 3, opposite over hypotenuse is the square root of 3 over 2. Both of these values are squared, so I get 1/4 minus 3 over 4, right? Square root of 3 squared is 3, 2 squared is 4. So 1/4 minus 3/4 is a negative 2/4, which is a negative 1/2. Looks like letter A. Simple product rule with my trig functions. All right. Next one. 11. Plug in negative 3, I get 0 on top. Plug in negative 3, my guess is I get 0 on bottom, but let's double check. I get 9 plus 6 minus 15. Yep, I get 0 on top and 0 on bottom. Two options. I can factor, or I can do L'Hopital. I'm going to do L'Hopital. So on top, I take the derivative and I get 2x. On bottom, I get 2x minus 2. Plug in a negative 3. On top, I get negative 6. On bottom, I get negative 6 minus 2, which equals negative 6 over negative 8, which is 3 over 4. Letter C. Had you factored, you'd have done fine. You'd have had x minus 3 on top. You'd have had x plus 3 on top. On bottom, you'd have had x and x. What would that be? Minus 5 plus 3. We still have the limit as x approaches negative 3. Positive 3 cancels, and I get negative 6 over negative 8, just like I did the first time. Okay? Number 12. Average rate of change. Average rate of change. Secant line, correct? Average rate of change. When I know a function and I want the average rate of change over a given interval, I'm thinking y2 minus y1 over x2 minus x1. Slope of a secant line. So I simply plug in pi over 2. Cosine of 2 times pi over 2 minus the cosine of 2 times 0 divided by pi over 2 minus 0. y2 minus y1 over x2 minus x1. This becomes pi, so cosine of pi, remember, is a negative 1. Cosine of 0, remember, is a positive 1. So I have -1 minus a +1. On bottom, I have pi over 2. So on top, I get -2. On bottom, I get pi over 2. Dividing by a fraction is multiplying by the reciprocal. So this becomes -2 over 1 times 2 over pi, and I get -4 over pi. Letter A. 13. Looks pretty much like a basic derivative. So I take implicit differentiation. So I get 3y squared times y prime. Power rule with the chain rule. Chain rule is the derivative of y. Derivative of y is 1 times y prime. The derivative of x with respect to x is just 2x. Okay? I got a problem. I get 2y primes. How do I get rid of, or how do I change the left-hand side so there is only one y prime? Because that's what I'm solving for. This means y prime, correct? I'm going to factor. If I factor out a y prime, I get 3y squared plus 1 equals 2x. And if I divide, I get y prime equals 2 over 3y squared plus 1. Switching the order around a little bit gives me letter E. Implicit differentiation. 14. So there's my graph of 14. My graph of y in question 14. It's a closed interval. Which of the following could be a graph of the derivative? There's my graph of f. Make sure you take a second and double check what function am I given. This is f. I want the derivative. Seems pretty straightforward. I know my derivative is going to be 0 here, my derivative will be 0 here, and my derivative will be 0 here. So where do I have a graph that has a derivative at all three of those places? Not A. Not, well, yeah, B works. Not C. And not D. Down to B and D. What do we have here? We have a function that is decreasing, so my derivative is negative. Well, that's D. B, my derivative is positive the entire time. Here my derivative goes negative because it's decreasing, and then it goes to positive because it's increasing, and my derivative is negative, and it's positive, and it's 0 right here. 14 is D. Question 15. All right, so we have one of those where you have to find out which of the statements are true. Question 1. The limit as x approaches 1 from the left equals the limit as x approaches 1 from the right. To evaluate a limit, I simply plug in the values. Plug in 1, I get 3 minus 2, which equals 1. On the bottom, plug in 1, I get 3 minus 2, which is 1. And the natural log of 1 is 0. So on the top, I get 1. On the bottom, I get 0. Question 1 is not correct. The limit as it approaches the left and the right are not the same. Okay. Next. Number 2. The limit as x approaches -1 of the derivative of f. Let's look at that. Derivative of f. So I get 3 on top, and I get 1 over 3x minus 2 times 3 on the bottom. Do we see that? I'll write it out a little more organized. I get 3 on top, and I get 1 over 3x minus 2 times the derivative of the inside function, which is 3. Now, find the limit as x approaches. I go to 1. My derivative is 3. Down here on the bottom part, I plug in 1. I get 1 over 3 minus 2 times 3, which is 1 over 1 times 3, which is 3. Correct. 2 is good. F is differentiable. Well, we know it can't be differentiable because question A was not true. A derivative or sorry, not derivative, a limit must have the same y value, or it must approach the same y value from the left-hand side and the right-hand side. So I know 3's out. So 2 only. C. (16) Functions defined by that thing. Application of the mean value theorem on the interval guarantees the existence of a C value. Find that C value. Mean value theorem. Average rate of change equals the instantaneous rate of change. So what do I need? I need the average rate of change. F of B minus F of A all over B minus A. Y2 minus Y1 over X2 minus X1. Saying the exact same thing. All right. F of 3, what does that look like? 2 times 3, 9, 27. Minus 4 times 9 plus 1. That's my plugging in of 3. Plug in 1, and I get 2 minus 4 plus 1. The parentheses I just threw in there are pretty important. Make sure you have them also. So I get 54 minus 36, which is 18 plus 1 is 19. So it looks like I get 19. Sorry, my writing is horrible. 19. We'll check. 54 minus 36 is 18 plus 1 is 19. All right, over here, I get 2 minus 4, which is negative 2, plus 1, which is a negative 1. Negative 1 makes it plus 1, all over 2, which gives me 20 divided by 2, which is 10. So I know my average rate of change is 10. So where will my derivative, what is my derivative? This is going to be 6x squared minus 8x. Where does that mess equals 10? Where will, let me get rid of this now. Where will 6x squared minus 8x equal 10? Where will 6x squared minus 8x minus 10 equal 0? I'm going to factor out a 2 just to make it a little nicer. So I get 3x squared minus 4x minus 5 equals 0. I get 3x and x. Did I do something wrong? I don't see an easy factor. 5 and 4, or 5 and 1. All right, I'm going to hit pause for 2 seconds. All right, I'm back. Sorry. I read the question wrong. They want to know, what does this value right here need to be? What is f prime of c going to need to be? It needs to be my average rate of change. 10. Sorry. Read the problem carefully. We are not looking for c. We are guaranteed a value of c, but we are not asked to find that value. We're trying to find what value does my derivative have to equal. What value does my instantaneous rate of change have to equal? It has to equal the average rate of change, which is what we found, 10. All right, good lesson for me also. Slow down and read the problem. All right, number 17. Velocity is given by that equation. H is the depth. Water's moving through waves, etc. What's the rate of change in meters per second? Right? What is the rate in meters per second? Oh, sorry, meters per second per meter. And what does that mean? Meters per second per meter. Looking for V. What are my units of V of H? V of H is velocity in meters per second, where H is the depth of the water in meters. So if I found dV dH, good lesson on units. If I find dV dH for meters per second, what are my new units? Are my new units meters per second per meter? Yeah, because dV is the change in meters per second, the change in my velocity, divided by the change in my meters, because H is in meters. So I'm simply looking for the derivative of this velocity equation with respect to h. Simple derivative. So I have 3h to the 1/2, that's not b prime yet, right? And so I get 3 over 2h, decrease the exponent by 1, I get negative 1/2. So this becomes 3 over 2 times 1 over the square root of h, which looks a lot like c. No? Yeah, looks a lot like c. Why? Because we're looking for it at 2. So I plugged in 2 for h. Okay? Showing my work all the way through, not skipping a step. This becomes 1 over square root of h, and so v prime of 2, that was v prime of h, equals 3 over 2 times 1 over the square root of 2, which is c. Okay? Number 18. We're rolling so far. Number 18, dy dt is equal to that mess. Y of 0 equals to that. What is y of 6? How do I go from y prime to y? I integrate. So I'm going to integrate this thing, but let's, before we do that, do I need to separate any variables? Well, kind of, sort of. I can really just integrate this, just bring the dt over here, and now integrate that and integrate that. So it's really just a basic integral. Integral of dy is just y. That negative 10 I'm going to stick out in front for right now. We can do a u substitution, or we can kind of think through it. Let's go ahead and do a u substitution until we get comfortable just doing it in our head. There's my u, right? The exponent is typically the u, and so my du is negative 1/2 dt, because this is really just a negative 1/2 t. It's the same thing as negative t divided by 2. So I multiply by, multiply by negative 2. Take the dt out, put that in its place, and so I get y equals negative 10 integral of positive 20, so I'm multiplying by negative 2. And I get e to the u du, where u is equal to my negative t over 2. Integral of e to the u is e to the u, so I get y equals 20 e to the u. And now I can stick my u back in, negative t over 2. Sorry, dropped my eraser. Negative t over 2. What do I need in here? Plus c, correct? So now I know, I'm going to jump up to the top of the board. Y of 0 equals 20. So 20 equals 20 e to the 0 power, right? Because 0 is my t, and 0 divided by 2 is 0. E to the 0 power is 1. So I have 20 equals 20 plus c, so c must equal 0. So now I go back to here, c is 0, and now I plug in 6, I get y equals 20 e to the negative 3rd power. Looks like letter B. Double checking my math. Looks good. Number 19. Let f be that function. F prime is equal to, f prime be that function. Where does a point of inflection occur? Where my second derivative is equal to 0. My second derivative, bring the 3 down in front, decrease the exponent by 1, subtract 4, add 4, sorry, I skipped a step, add 4, divide by 3, square root So it looks like letter C is the only one. There is no negative. So we're good. That was a nice quick one. Number 20. Let f be that function. Y equals b is a horizontal asymptote to that graph of f. And b must equal what number? Basically, where does my horizontal asymptote occur? In general, where do horizontal asymptotes occur? At relative extrema, correct? Relative extrema occur where my derivative is equal to 0. Horizontal asymptotes happen where my derivative is equal to 0. That is f. F prime. You want to do product rule and quotient rule, or do you want to multiply that mess out and do just quotient rule? It doesn't matter. I'm going to take 5 seconds and multiply it out. So I get 2x squared minus 3x minus 8x plus 12 on top. And on bottom, I get x squared minus 2x plus 1. Combining some like terms on top, I get 11x here in the middle. We have a nice little problem there. And I'm going to take the derivative of that thing. Derivative of the top, so f prime of x, derivative of the top is 4x minus 11 times the bottom. Oh, I got a mess. Maybe I should not have done that. I don't want to do that. Sorry, for those of you who want to keep rolling with that, keep rolling. I think it's going to be easier without. So derivative of the, I have a product rule, right? And I have a quotient rule. So in my quotient rule, it says take the derivative of the top. But the derivative of the top is a product rule. So derivative of the first times the second minus the first, whoops, minus the first times the derivative of the second. Okay, so there's the derivative of the top. Times the bottom minus the derivative of the top times the bottom minus the top. Oh, this isn't any better. Minus the top. Holy cow. Times the derivative of the bottom. All over the bottom squared. Wow, they're not very nice. Holy cow. All right, let's work it out. So what do we got here? I see inside this parentheses, I see, I'm going to have to jump down here, 2x minus 3 minus 2x plus 8. Do we see that? 2x minus 3 in the first part, minus, distribute that 2x, I get 2x plus 8, times x minus 1 squared, minus, over here, what do we have? Well, I'm going to take and do some rearranging right away here. I got x minus 4. It probably would have been faster to multiply that out and keep going. So I get 2x squared. That was the same one we had, minus 11x plus 12, right? That didn't save us anything. And this is a 2x minus 1. All right, so what do I notice? I notice I have an x minus 1 here. I have an x minus 1 here. And I have an x minus 1 on the bottom. So now I have just 3 of them on the bottom. All right, so that wasn't so bad. So now we have this and that cancels. I get negative 11 times x minus 1 minus 2 minus 4x squared plus 22x minus 24. Distributing the 2 into those terms and the negative sign. Woo! All right, this is a fun one. Do I care about the bottom? I don't, but I'll keep it in there just for the fun of it. Why? Because I'm looking for where this fraction is equal to 0, and this fraction is equal to 0 when the top is 0. So all I really care about is the top. All right, so I have that Combining like terms, I have negative 4x squared plus 11x minus 13. After all that work, I probably made a mistake somewhere and it's not going to come out nice and neat. I'm going to get rid of the negative sign just because I can. I think I made a mistake somewhere. Oh, I don't like making mistakes. So I have 2x, 13 doesn't give me 11, 4x and 13 doesn't give me 11. All right, I got to find my mistake. I'm not going to put you through the torture. Give me a second. All right, I'm not going to waste any more time. I just redid what I was doing at the beginning. I multiplied the top together, and I took the derivative, and I simplified. I'm going to let you look at that. Hit pause if you want to look at that. I had to make a mistake somewhere because I got 7x minus 13 equals 0, and the answer is 2. And I got almost 2. That needs to be a 14, not a 13. I don't like this. The first one I've missed out of all the tests. I made a mistake somewhere, so I'll have to go back through and look at that. But you can look through that, see my work, and give it a try. Answer should be C. Whoops, wrong direction. Wrong direction. Answer should be 2. We'll move on. We'll try that one maybe in class tomorrow. All right, 21. Get rid of my mess down here. That was a messy problem. I might think of another way of doing that one. That was just off the top of my head here. All right, base of solid regions bounded by that equation. We should know what that looks like, right? If I had x squared plus y squared equals 1, and I solved for y, I would get that equation, correct? So that is a semicircle with a radius of 1. The top half of a circle with a radius of 1. That's what that is right there. Okay? So we have that region bounded by the x-axis and the graph. Okay? Which is fine because that graph is only the top half of the x-axis anyways. And so we have that nice section right there. For the solid, each cross section perpendicular to the x-axis is a square. So I have this guy coming down here and then comes up off the paper and makes a square. Okay? So these thicknesses are dx thick, and my height is my equation. So I'm going to integrate that square root of 1 minus x squared with respect to x, and I'm going to square that. Why am I going to square that? Because this is the length, and it is also the width. So it's going to be that mess squared. Not because I'm finding the area of the region, but because I'm finding the volume of squares coming up off. And so I technically have length times width times height, which is why my dx, or my thickness, which is why my dx is pretty important. Or you could say I have length times width times height. However you want to visualize that. I have 3 dimensions in a volume. I have a length and a width and a height. The dx is part of that in there. All right. The square and the square root makes that go away. That was kind of nice. Integral of that becomes x minus 1/3 x cubed. Forgot something. What are we going to integrate between? We could do this 2 ways. I can integrate from 0 to 1 and double it, or I can go from a negative 1 to 1. I'm going to go from 0 to 1 because zeros are usually nice, and I'm going to double it. So I'm going from 0 to 1, and I'm going to take my answer and multiply it by 2. Plugging in 1, I get 1 minus 1/3. So here I get 1 minus 1 cubed is 1, so I get 1/3. Plugging in 0, I get 0 minus 0, which is 0. 1 minus 1/3 is 2/3. And 2 times 2/3 is 4/3. Whoops, looks like my answer is letter B. All right, we have a few more. And I have 25 minutes. We'll make it. We'll at least get this part done. All right, there's f. K is some constant. for what values of k, if any, is f strictly decreasing on the interval? Decreasing happens when my derivative is less than 0. So let's find the derivative of that thing. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay? Where will a fraction be negative? When they are opposite signs, correct? When one's a plus and one's a minus. Well, look at the bottom. That's always plus. X squared is always positive. When you add 1 to a positive number, it's always positive. So all I have to look at now is the top. So when will the top be negative? So let's distribute that k. I get kx squared plus k. Let's multiply those together, and I get minus 2kx squared, right? Minus 2k, the x times the x is x squared. And I want to know where that's equal to 0, so then I know where it's less than 0. So I have minus kx squared, because I have a positive kx squared, and I have a negative 2kx squared. So that gives me a negative kx squared plus k has to equal 0. Let's factor out that k, and I get 1 minus x squared. No, I won't rearrange it on you, sorry. Negative x squared plus 1. Where's the thing 0? Would you agree at plus and minus 1 is where that thing is 0? So when x is, what was my x value? In the interval from negative 1 to 1, where is it strictly decreasing? So in the interval from negative 1 to 1. So on my number line, this part right here is 0 at a negative 1 and 1. So the whole thing is 0 from a negative 1 to 1. I'm going to stick 0 in there. So when x is between a negative 1 and 1, let's say 0, what is the sign of this piece right here? It's positive, correct? Does it change anywhere in there? What if it's 1/2? Well, then this is like a fourth, right? That's a fourth plus 1, that's positive. So everywhere in there, that's positive. Where is k? For what values of k is it strictly decreasing? So in that interval, we're saying our function is, or this, I got so many lines here, sorry. Let's start over. We're saying this is always positive in the designated interval. So what does k have to be in order for this derivative to be negative? K has to be less than 0, right? Okay. I think that was it. Yep. 23. Which following equation? Following is an equation for the line tangent to the graph given. Equation for the line tangent to the graph. What do I need in order to find the equation of a line tangent to a graph? I need a point and a slope, right? Well, I'm given an x-coordinate. Let's go for the point. Notice I am finding the full equation, not just slope. I am finding the equation. So I want y. So I have negative 3, integral from negative 1 to negative 1. Do I need to keep going? What is the integral from a negative 1 to 1? 0, right? So that's 3 minus 0, which equals 3. That part wasn't so bad. So my point is negative 1, 3. Can I eliminate anything? Nope. Too bad. All right. Derivative. So the derivative of this thing, derivative of 3 is 0, correct? The derivative of an integral cancels the integral, but I got to plug in the upper bound, and then I got to multiply by the derivative of the upper bound, which in this case is 1, so I don't really need that. And I want my slope at negative 1. So I put a negative 1 in there, and a negative 1 raised to the negative first power, negative 1 raised to the third power is a negative 1, times a negative 1 is a positive 1, so my slope at a negative 1 is plain old e. to the first power, which is just e. Looking at that answer, oh, no. Looking at that answer, I don't see plain old e. See a negative e. I missed the negative. Oh, forgot my negative right there. There's a negative in there. Okay. Got to slow down. Letter B. Sometimes we get lucky and the answer that we have is not the right one. Had they had E in there, I probably would have picked it and made a mistake and forgot my negative sign. But I got lucky. They didn't give me just plain old E. All right, double checking the answer. We did get the right one. All right, 24. Which of the following is a solution? We're going to do some integrating, right? So dy dx equals 5y squared. I'm going to separate some variables, leave the 5 alone. I get y squared coming down here. I get 5 dx over here. This is not ln, correct? It is not ln. It is not y to the negative first power. This is y to the negative second power. Now I'm integrating that. And when I integrate, I add 1 to the exponent. Divide the old coefficient by the new exponent. And over here, I just get 5x plus my c. Initial condition, when x is 0, y is 3. So this becomes a negative 1/3, right? 3 to the negative first equals 5 times 0. So c is a negative 1/3. And so I get negative y, so negative first, equals 5x minus 1/3. Double checking my math. I've made a few mistakes tonight. All right, so now I have negative 1 over y equals 5x to negative 1/3. I'm going to switch places. So I have negative, well, maybe you don't want me to switch places right now. Yeah, I don't care. Either way, we're going to have to deal with a fraction. I'm going to switch places. See how good we are with fractions. Either way, it's going to be a mess. So, my next step, I need to multiply top and bottom by 3 to clear my fraction. Right? So I get negative 3 on top. I get 15x minus 1 on the bottom, multiplying the top and the bottom by 3. And when I multiply the bottom by 3, I multiply everything by 3. And that gives me y. I could have done that right here also. Multiply both sides by 3. And when I multiplied the fraction, I would have got a negative 3 over y. When I multiply the right-hand side, I would have had a negative 15x minus 1. And then I would have switched places and got the exact same answer. What is that answer? 1. Sorry, let me grab this mess. I can't keep track of what I got going here. Well, that helped. Okay, let's undo that. And let's undo that. And, all right, we can do this. Smarter than the average cat. So we get 3 over 1 minus 15x. 3 over 1 minus 15x. Wow. 3 over 1 minus 15x. D. Sorry. It's like almost 8 o'clock at night. I am definitely too late to be here at the school. All right. Question 25. Almost done. This is my definition of a derivative. We need to recognize that. Definition of a derivative. How do I know? It's my limit as h goes to 0 definition. So really what I have, f of x equals sine x. This is my function. Remember the limit definition. I don't know if I've seen this one on every single practice test we've done, but pretty close. Whoops. Here's my limit definition. f of x plus h minus f of x all over h. So this second function is my function. So sine of x is my function. So what am I looking for? I am looking for the derivative at pi over 3. How do I know that? Because it's pi over 3. My x is pi over 3. So find the derivative. F prime, derivative of sine is cosine. Take the cosine of pi over 3. We already did this earlier. Cosine of pi over 3 is a half. 25 is B. Gotta like those quick ones. 26. Object moves along a straight line. Velocity is given by that. What is the distance traveled? How do you go from velocity to distance? A lot of you write on your papers PVA. Velocity to distance is integral. Distance traveled is the absolute value of velocity. Do I need to worry about absolute value if time is greater than 0? Object moves along a straight line so that at any time greater than 0 is velocity given by that. What is the distance traveled from t equals 0 to the first time it stops? If we're looking for the first time it stops, then it never had a chance to turn around and go backwards, right? So I don't need to worry about the absolute value. Distance traveled is only going in one direction. I don't have to worry about absolute value. I do need to worry about where is my velocity 0. Where is the first time that that's going to be 0? Divide by 2. Where is cosine 0 first? I can do it on a unit circle, or I can do it on my curve. On my curve, cosine starts at 1, and it's 0 right here. What is that t value right there? Pi over 2, right? Those of you who like unit circle, it starts at 0. Sorry, it starts at 1, and it's 0 up here at pi over 2. All right. So pi over 2 is my first. We're not done. Divide. So we're integrating to pi over 6. So I'm integrating from 0 to pi over 6 of 2 cosine of 3t. Bring the 2 out in front. 0 to pi over 6. Derivative of what function is cosine? The derivative of sine is cosine, right? For those of you saying, oh, we need u substitution. I know. I'm going to do it just a little different way. The derivative of sine is cosine, right? If I were to take the derivative of that right there, the derivative of sine 3t is cosine 3t, times the derivative of the inside function, I would generate this 3 that's not out there. How can I get rid of that 3? I can stick a 1/3 in front. I just did a u substitution thinking backwards. I like doing that sometimes. I just need to undo this guy right here that's going to show up when I take the derivative. All right, integrating from 0 to pi over 6. That's a horrible 6. All right, so I have 2/3 now out in front. Ignore that for a second. Plug in pi over 6. The sine of 3 times pi over 6 is the sine of pi over 2. Minus, plug in 0, the sine of 0. That's not a theta, that's a 0. Okay, and so I get 2/3. Sine of pi over 2 is 1, sine of 0 is 0, and I get 2/3. Answer 26C. 2/3. All right. 27. Table gives select values. Differentiable and decreasing function. Okay? It's a differentiable decreasing function. And its derivative is given up there also. If f inverse is the inverse function of f, okay, what is the value of the derivative of the inverse at 2? Some of you like things like this. F of x equals g of, f inverse of x equals g of x. If you like that better, we are looking for g prime of 2. Okay? Remember our rule. It is going to be, just in general, 1 over f prime of g of 2. What is g of 2? This here says f of 2 equals, no it doesn't either, it says f of 1 equals 2. If f of 1 is 2 and f and g are inverses, then g of 2 has to be 1. So what we are looking at now is 1 over f prime of 1. F prime of 1 is a negative 8, and we have 1 over a negative 8. 27 is B. I would memorize that formula. And if you want to stick f inverse prime in there, you can do that. What do I need in here? I need a parentheses there. Okay? Well, that gets pretty cumbersome with your notation. Just recognize I'm calling f inverse g. So now this is just g prime. Makes a little nicer notation. Right, need to know that one. Shows up on every single test. Question 28, we have a related rates problem. Can tell by the setup. Top of a 15-foot ladder, it rests against the wall. Bottom of the ladder is sliding down, the top of the ladder is sliding down the wall at a constant rate. At what rate is it, in radians per second, is the acute angle between the bottom of the ladder and the ground? The acute angle at the bottom of the ladder and the ground. The instant the bottom is 9 feet from the base. So I'm going to call that x. I'm going to call that theta. What else do we need to know? Do we know the height up the wall? No. But I do know the 15-foot ladder. Is that 15-foot ladder a constant? Yes, it is. So I can write it in there. I don't really even need to know Pythagorean theorem right at this second, because I need somehow to write a relationship between x and the 15 and the theta. I'm looking at cosine. Cosine is equal to the adjacent over hypotenuse. How do I know when I can plug in a value for the side length and when I have to use a variable? I put a value on the ladder and I put a variable on the bottom, even though they told me what my x was going to be. How come I can put a 15 in, but I can't put a 9 in? Because the 15 is a constant. The length of the ladder does not change. The length of the base or the bottom between the wall and the ladder, that does change. So I have to leave that x as a variable when I write my initial condition or my initial equation. All right, I'm going to make this a little easier just to get rid of the fraction. All right, take the derivative with respect to time because it's in feet per second. We're doing this thing with respect to time. Okay, so the derivative of cosine is negative sine. So I have negative 15 sine theta times d theta dt. And x, derivative of x is just dx dt, 1 dx dt. All right? And they tell me at what rate in radians per second is the acute angle between the wall, etc., changing? I'm looking for d theta dt. I know this is 9 now. I know that's 15 now. What is the sine of theta? Sine of theta is opposite over hypotenuse. Well, I got a 9, I got a 15, so I have to do a squared plus b squared equals c squared. If you know your special right triangles, we could have done this one also as a special right triangle. But I get 81 plus b squared equals 225. I square root, and b squared equals, I don't square root yet, sorry, I subtract 144. I square root, and b equals 12. Remember your 3, 4, 5 triangle. If this is 3, and this is 4, and this is 5, 9 is 3 times that side, 15 is 3 times this side, so that would be 3 times that side. If you saw that, you would know that the sine of theta, or you would know that that side's 12. So sine of theta is opposite over hypotenuse. So this becomes that. I'm looking for d theta dt. They said dx dt is the ladder sliding down the wall at a rate of 2 feet per second. Okay. Oh, that's a bummer. I shouldn't have done that. I was looking at it sliding out from the wall. It's sliding down the wall. Can we change this really quick and call this y? Sorry, it is really late. So I'm going to change this to the sine of theta equals y over 15. Using the same logic, I'm going to go 15 sine of theta times d theta dt equals, oh, sorry, I haven't taken the derivative yet, equals y. So I go 15, derivative sine is cosine theta times d theta dt equals dy dt. I just had to see why it changed. Those of you who are wondering, what is he doing? I need to write a relationship between what I know and what I don't know. And I know the 15, and I don't know the y, and I'm looking for the rate at which the y is changing. That's why I had to change. Sorry. It's the last problem, luckily. And I'm out of time. So we have cosine of theta now, not sine, which is 9 over 15. They didn't have to calculate that. They told me. And d theta dt is what I'm looking for. All right, back to my question. So it is sliding down the wall at a constant rate of 2 feet per second. So y dy dt now equals a negative 2 because my y value is getting smaller as we go. So it's negative 2. There's an equal sign in there. So that cancels. I get 9 d theta dt equals negative 2. And so I get negative 2 over 9. And that better be up there. It is. 28 is A. And we got it right. Wow. Sorry. That was brutal, those last few. I hope the thought process helped. We can talk about it in class. And tomorrow in class, I'll apologize profusely. All right. Hope that helps.